Right, can you see that?
Yeah. Yeah.
This is just a few comments about astrophotography, or really what we're trying to get when we're taking a photo. Now, a few weeks ago on the BAA webinar, there was a really good, interesting talk by an American guy, and he made the point that if you take a picture like this, which is a Hubble one, the colors are they real or not? They fit the filters that are in use, but he pointed out that if you were to go somewhere where you could see this, present this view yourself out in space, your eyes wouldn't be sensitive enough to pick up the colors. They're just not, they aren't sensitive enough. And so you went, well, is it real? You could never see it, but is it real? Well, I think you might as well have the colors if there's some hint of them, even if they are that weak. But anyway, it just made me think a bit about, well, what are you trying to get with an astrophotograph? And here's another one, the colors here and the detail. Well, if you were to go off to this place and you looked out of the spacecraft window, would you see this? And I suspect you probably wouldn't, because again, these colors are much more subtle than this rendition shows. But on the other hand, if you want a poster of a nebula, you want to see it, and this is it. So that had me thinking. Now, another thing which is I've been thinking about, I've been looking at the Astronomy Photographer of the Year award, which was a couple of weeks ago, and actually I've got a book of last year's one, or a compendium, which is really good, really excellent to look through. But here's a picture which was highly rated this year, and my problem with it really is that, yeah, there's the Milky Way. That would have been a very long exposure, or lots and lots of exposures stacked up. But if I was to do that and have a foreground object, well, the foreground object isn't going to move, so it will blur. If you stack to get the Milky Way as the way it is, then objects that aren't moving with the stars will blur out. So this is a composite. This top bit is one picture, and it's been put in with this other one, and it's even worse than that, I think, because if I was to take this picture, I'd have to change the aperture to get this tree thing, which isn't too far away by the look of it, in focus, as well as at the back. And I just feel the picture has become too synthetic. You fiddle with it too much to get that result. But the judges don't care anymore, or at least it's commended. Now here's another one. There's a lot going on here, and this is from this year. I don't know if it won, but was it last year? But it's very highly commended again. And there's lots going on, and you can see, yeah, that would have been a long exposure to the sky, or lots, and yet you look down here and look, everything is very, very clear. There's no blurring of these foreground objects. And this one here, this is in focus, and yet it's pretty close. Now, again, not only is it, not only have you fiddled with the timing, you've had to fiddle with the aperture, in at least, well, combining two pictures. And I'm not sure about it. I mean, if you were to go there and to look and sit on the ground and look up, would you see this? Well, no, because the tree would be too dark, presumably. And your eyes might, you probably could see this sort of thing. I mean, I've seen that sort of thing in Australia. So that's kind of real, but to get all that as well, all right, well, it's a nice picture. So that's maybe its main value.
It's a composite, isn't it? It's two pictures.
Well, it definitely is. Now, you can go further than this. There's a lot more of this kind of thing going on. Here's another one. This is actually, I can't remember where this is. But anyway, you can see there, look, you've even got Bernard's Loop there in Orion. Gosh, that's pretty struggle. And yet at the same time, you've got a nice sharp beach. Yeah, it's lit up presumably by residual light and lighthouse here. And this is all light as well. but nonetheless, it's all very sharp, and so is this. So again, that's an absolute composite. Well, fine, but I mean, I think it's not a photograph, it's several. So anyway, I was wondering about that, but also here, now this is the hydrogen alpha of the sun, and these days the sun isn't like this very much, even when you get to see it. But the general features you get are these filaments like here, and then around the limb you get prominences. Well, filaments and prominences are the same thing. It's just that the prominences are against the sky and the filaments are against the solar disk. Now, when I try and photograph these with my Pentax, my hydrogen alpha telescope, I find that I can't expose for both at the same time. I can't get the prominences and the surface detail in the same shot. I have to massively overexpose the disk to get filament to get these prominences. But anyway, here this is clearly a composite because that there and that there should be the same brightness, and they're not. So okay, you know, it's an effect again. But here's another one. Now this is the same thing. This is there isn't a filament on this, but you can see that these are rather bright. Now I can see things like that through the telescope, but I can't photograph them. My eye can sort of accommodate, but the camera can't. That would have to be 2 shots for me combined. But it reminds me here. This is on a good day what you might like to see, and the prominences here are the same brightness as that filament there. Now sometimes you can see it when the filament goes right up to the edge. And becomes a sort of prominence as well, then it's clear to you. Oh yes, it's the same thing. But it reminds me of this optical illusion. A and B here, which is the lighter or the darker? Well, actually, they're both the same. But it's a classic illusion, and to some extent, the solar disk one is similar. Here's a better example where there's a nice filament, and just as it gets to the edge, then it becomes a prominence, and actually, well, when you see it on the telescope, it's the same red color. So there it is. So that looks to me to be more of a single shot. Again, I think this one, I can't remember if it's prize winning or not. But anyway, so that was something that I was wondering about, is to what extent are you prepared to manipulate your pictures in order to present them? And well, I'm not sure I would do this. I mean, I wouldn't mind having this picture, but if I had the camera. But anyway, there we go. Now, this is what I wanted, the main thing though. This won a prize this year. This was one of this year's prize-winning astronomy photographer of the year pictures. And of course, it's the Andromeda Galaxy, which you've all seen many, many times. But the effect the guy has achieved here is the stars here, they're out of focus. So it looks as if the illusion is, or the impression is, that you're looking through a lot of foreground objects and the galaxy is behind them. And that was such a striking feature that he got a prize for it, despite the fact it's a photograph that, you know, something we've all taken pictures of. There's nothing special about the galaxy as such as a photographic subject. Now, interestingly, the way he did it, which I think is as a purist is fine, he actually tilted the camera on the telescope. He apparently had a 3D printer and made some sort of adapter that could do this. And if you look, because the galaxy is elongated here, it's like a band across the middle. And the thing is, the sensor, if you like, is on a slope. But this middle band is all in focus, and yet above and below are out of focus. But because you tend not to notice these ones on the flanks, you get the impression, oh goodness, I'm looking through a starscape, a distant object, and the nearby ones are blurred. And I thought that was a really interesting effect. I was wondering, gosh, yes, you actually look at it maybe in a different way. You do get a sense of the 3D vector of space, which very often you don't. Anyway, I was wondering whether we could do this ourselves. And I don't have a 3D printer. I can't make a sloping adapter, but this is one of my pictures of Andromeda taken with my Pentax, which is self-tracking. And I was wondering, well, maybe if the stars are not very small here, because the tracking isn't perfect, and in fact you can see where it breaks down a bit. Some of them are a bit, well, you can see that. Maybe I could get a similar effect. So anyway, here's what's this one? Oh, this is M33, I think. Again, taken with the Pentax. Again, the stars aren't particularly sharp, but what it would be nice if you can blur them up, and yet still keep some, well, maybe hopefully a bit more sharpness than this of the galaxy. I can think of a few tricks to do that. You could take a band at the top here and a band at the bottom, and a band also down the sides, so the middle bit gets left, and just blur them and then add them back together and add them back on top. But is that cheating when making the camera's sensor slope? Really wasn't. I'm still thinking about that. This is a picture of M51. Again, it's a crop from a much bigger picture, and there's all sorts of light pollution, and in fact a satellite going by. The stars aren't particularly sharp at all. I mean, distinctly not. It's an effect I might think more about. There's zooming in a bit more. You can make out the spiral nature, but it's not that sharp. It's not hugely well defined. The stars are not really blurred enough to give the effect. But anyway, it's an idea. Now this is M101, I think, a wide shot. There's light pollution here. I think somebody put a light on halfway through the run, and you can even see the shadows in the light of the curtains, I think, there. But anyway, there it is, and you can zoom in a bit, crop it in. Now this is, if I could blur the stars and keep that there sharp, that would be the effect, wouldn't it? You almost get it here, in fact. This galaxy is behind all this stuff, but not quite strong enough. This is zooming in a bit more. Yeah, there it is. The stars are a long way from being points, but not really enough to qualify as being blurred. But anyway, so there we are. That was the thought. It may be a little bit of imperfection in the pictures. Is something to think about. And oops, there we are. But I just wondered about it. I mean, do I need another picture of M31, you know, as is? Well, no, not really. But if I could make one that did give a 3D kind of effect, and maybe try that with other galaxies, I think that might be interesting. I think it's the sort of thing that would stop people would stop and look at if we ever do them again, any exhibitions or stalls or anything.
I think it all depends what the people who award the prizes are looking for.
Well, yeah, it's not.
If they're looking for an artistic shot, then you can do anything. If they're looking for astronomical realism, then they don't qualify. But if all they want is just a nice picture,
yeah, exactly.
Well, it seems to be moving that way. Yeah. But anyway, I just thought there were some ideas there, rather than strive to try and get perfect all the time. And I haven't got the patience for a lot of these things. Maybe something a little different, that kind of idea, might be worth it.
I get what you mean about those pictures that you showed as examples being artificial looking. I've always, well, you know, I've seen lots of these sort of pictures. I've even got, I think, the same annual that you were mentioning with all these pictures in, and they don't do a lot for me. They're suspiciously artificial to me.
Yeah.
I must admit, I don't like them all that much. They're pretty, but what other worth they've got is questionable.
Well, they're a bit of a nine days wonder, aren't we? We humans rapidly get used to things, seeing things.
Yeah.
It's like all these panning nightscape videos that we used to get 2 or 3 or 4 years ago. You don't seem to see them so much now because everybody says, "Oh yeah, I've seen that before." It does remind me a little bit of, well, crikey, nearly 5 decades ago now, crikey, in the Cleethorpes Society, we used to hold these annual astrophoto competitions. This is way back in the age of film, of course, and most of our efforts were pretty scrappy by modern standards. But the audience at the club meeting were the judges for the competition. So the pictures were shown as slides, and then judging went on, etc. And one year, amongst all this drab stuff which most of us were putting up, a slide went up of Saturn. Huge rings, couple of moons on it, and I thought, one of those moons is a golf ball. And I looked at it and I thought, this is not the genuine article. But of course, because it was visually impressive, it took the prize. But somebody had built a model of Saturn, photographed the model in black and white, as I recall, made a slide of it, and there you go. But most of the audience were not that discerning, I'm afraid. So.
Well, somebody a few years ago said to me, and I'm sorry this is backtracking, but coming back to what Robin said, somebody said to me a few years ago, he said, "Dave, I'm thinking of taking up astronomy." He said, "If I go out," he said, "I've seen some of these fantastic images, like the ones that John showed at the beginning, the different things that are very wonderfully technical." He said, "Is that what I'm actually going to see?" And I said, "No." So it almost does come back to this thing of, do you want a wonderfully aesthetically good image, or do you want something that's actually realistic and shows you what you're likely to see, or even what, I don't know, a telescope in space is going to see? I mean, if you want a nice, pretty picture, yeah, fine. But you think, personally, I don't want that. I want to see what's actually there,
I think it's worse than that, David. I think when I first started with a telescope, I was absolutely delighted to see Saturn in the eyepiece.
Yeah,
I thought it was brilliant, and I called my wife over and said, "Look at this, that's Saturn." She said, "Not very big, is it?" but I mean, I could distinguish features that. But then, sitting on the coffee table, there was a book with a Saturn that was 10 times bigger than the one that was in the eyepiece, in this glorious Technicolor. But the thing that concerns me is the false imaging that's done from the space program. You look at real pictures like from Curiosity on Mars, and it's all a bit blurry and a bit sort of foggy and a bit dull. And then you get another picture which is absolutely pristine, and it shows all the surface features and everything. And I just wonder whether this photo manipulation isn't actually doing something that we ought not to see. Yes, it's bringing out certain features, but are they the right features?
No.
Well, it's always been done with spacecraft, though, hasn't it? I mean, if you recall when Mariner 4, for instance, went past Mars in what, 64, 6, can't remember now. And the image that it got back, and it's 256 levels of grey.
Yep.
If you've seen the originals, you can hardly see anything at all on them. Even with the processing that they had in the mid-60s, they had to process them before they could. When they processed them, they were still grotty.
But the bottom line is it the real thing?
Yeah.
Or is it just something that we'd nice to look at?
Well, if you've been riding on the spacecraft, you would have seen a lot more detail, I suspect.
Well, I mean, you could say. I mean, I've seen wildlife, natural history pictures, been incredible pictures, but you almost think as though the animals have been posed. The sort of, you're there thinking, well, somebody's obviously hung around for ages and ages and ages and ages, and then they just think, oh, great, fantastic, they're in the right position, take the picture, and you think, Okay, that's fine. But changing subject entirely to what Ray was saying weeks and weeks ago, you know, and I mentioned it. When you look at Matthew Brady's pictures of the American Civil War, and he's got pictures of the Civil War battlefield, and he got people to go and put the dead bodies, rearrange them, so they're in nice positions, and then you take a picture. This is the battlefield, right? And the bodies aren't actually where the bodies have actually fallen, nor are they actually in the position they were when they fell, but they've been arranged in a very nice pose. And then you take this picture, and then someone says, oh, that's a wonderful picture. And like you just said, Bill, yeah, but is that real? Do you want the real picture, or do you want the nicely posed, you know, aesthetically pleasing picture that people will say, oh, that's wonderful, I'm going to put that on my wall, that's absolutely terrific, you know?
It seems that this is a universal, almost a universal, people just can't seem to help themselves. The same thing happened with First World War pictures and even films. Some of them were actually were posed.
Yes.
And the bodies weren't where they originally fell and all this kind of thing, yeah.
Yes. There is.
I've got a picture of the bridge at Edinburgh over the Firth, and it's a World War One picture, and there are 3 biplanes, distant biplanes in the sky going over the bridge, and the guy who did it painted them in.
Yeah.
Because it was for some wartime journal or something, and he painted them in. And it's the first thing you look at as soon as you see this picture. You see these 3 little dots in the sky, and you realise what they are.
Well,
in a similar way, is it Sutcliffe who went round photographing Whitby?
Yeah.
And evidently, a lot of his most famous pictures are all put-up jobs. You'd spend, you know, half the day getting, for instance, the baker to sit on the back of a wagon with the chimney sweep, you know, so he can have a nice contrast. And, you know, nothing is real. But personally, I think for the sort of stuff that we do, the thing that I want to see in an astronomical image is information.
Yeah.
What people nowadays call data. I mean, one of the first photos that John showed us, you could see what was oxygen and what was hydrogen alpha. And that's, to me, that's useful. Tells you what that particular section is made of. And, you know, I want to see anything that can give accurate information. And I agree that does not include photograph golf balls.
But it does include images that are things you could not see with your naked eye, doesn't it? I think you've got to look at what the purpose of a picture is. And if the purpose is to reveal structure that some physical object has, then it's not really relevant whether that's exactly how your naked eye, if your naked eye cannot pick up part of that structure because the light is so faint. But talking about pictures that are fabricated, but nevertheless trying to reveal something about what something would look like, whether it's the amount of carnage in a war by bringing lots of the bodies together, or what about Naismith's attempts to do models of the craters on the moon using plaster of Paris, and then they were photographed, these craters, and put in his book as if to represent the craters on the moon. I'm not sure whether he came clean at the time that they were merely plaster of Paris models. Ray might know, because he, like myself, has seen the original models at the Science Museum Reserve collection. But were there any protests about that? And should the protests, if there were any, have taken account of what the image was trying to get across, and whether that was legitimate as a way?
I don't think Naismith actually claimed that they were photographs. to begin with, nobody would have believed him because it was technically impossible at the time to do that. But I don't remember what he said, because he wrote it with this chap called Carpenter, the book where those images appear first of all. I can't remember offhand what he says about them. He probably came clean at a meeting, or if not in the book itself, I don't know. But it's true, isn't it? It's like Hook's drawings of a flea or a fly's eye or something like that. So science does this, doesn't it? It invents technologies which take our senses however many steps and leagues beyond what we can perceive ourselves, and into realms where really it's very almost difficult to credit. It's like ion microscopes or whatever, which can show atoms or the patterns where atoms lie. Are they real atoms, or are they just sort of statistical representations of where the atoms might lie? You know, it's a subtle thing sometimes.
It's one of those things that if I had a wish, it would be that my electromagnetic spectrum sensitivity of my vision would be just that little bit wider, so I could see the infrared and the ultraviolet as well. Which just probably, there's a picture in this month's Sky at Night magazine of Jupiter in, I think it's the infrared. No, it's ultraviolet, and it's pastel colours. It's beautiful. It really is. We can't.
Bill, if you're a fly, you can see in ultraviolet. And if you're an owl, you can see in infrared. But for whatever reason, we've not been gifted that particular ability.
But perhaps that's why we feel cheated's not the right word, but that there are additional things being included in the image. And if it was there, I remember when I started photography, my tutor said, if it's not in the print, it's not going to be in the image. And if it's not, you've not set the camera up properly, it won't be in the print, in the image. The image that we see that is produced, it's manipulated. It's not what is there. And I think that's, to me, the dividing line is what is real and is added because there is extra data, as Rod says, or is being manipulated in such a way that it's being mangled and changed.
Ansel Adams, the American photographer of landscapes, he very nearly became a concert pianist, but he went into photography with large plate cameras instead. And he said that when he very carefully crafted his negatives, checking every emulsion pack and doing his exposures very carefully, etc., developing according to his requirements. And he used to say that making a print from a negative, once he got the negative, was a bit like doing a concert performance. It was never the same twice. Depended how you felt on the day.
I think also if you're going to do something to extract extra data that's not, sort of normally visible or normally able to be seen, that you should do something with that data, not just do the images and then not do anything with the data.
Have we heard of John's views on this yet?
No, I think it depends. What is the picture for?
Yeah.
Well, exactly.
I think some of these ones, the nightscape ones, if it's understood that it's a composite, fine. But I sometimes think it isn't, which I'm less than happy about. But no, what's the picture for? There was always this problem with magazines, particularly photoshopping everybody, making people faces a bit different, making them a bit thinner or whatever. That got really out of hand. I don't think we're quite like that, but it's just now and again. I've found some of the pictures in this astronomy competition, they weren't really astronomy pictures. some of them obviously are, they're superb, but these composites with night skies and lit up foregrounds and everything, I think, well, no.
That's the key question, isn't it? Is the prize being awarded for artistry or astrophotography?
Yeah. I think as a general point, I mean, I've got various pictures and stuff on my wall here, not my astronomical pictures, but I've got a very famous painting of Henry VIII. And you look at it, you think, what a lovely man and what a handsome man. Now, at the time when the painting was done, he was suffering from varicose veins. He was overweight. He had no end of health problems. He was definitely not a very attractive man. But the image was painted as royal propaganda to give this idea of, look at this wonderful, magnificent specimen of a human being. And by the way, he's your king. And like we were saying earlier, what's the purpose of the image? If the purpose of the image is to create a nice picture, but it's even more than that. It's a nice picture. I mean, coming back to what John Arnold, what he said, John, earlier, are you taking a picture because you want a nice, I don't know, realistic picture? Or are you in competition with 100 other people or more than that in order to get the prize for astronomical picture of the year? Now, if you're doing that, bugger realism, it's basically whether your picture wins the prize before anybody else wins the prize. And if that's the purpose of taking the picture, then realism or naturalism or whatever you want to call it goes out of the window. You know, it's, oh, you've got a lovely picture here. Yes, so we'll give the prize to this person. But it's a bit unfair if somebody's there patiently taking what they think is a real picture and they're getting overlooked because, as I say, it's not what the judges are after. The judges are after a nice, lovely picture that, as John says, breaks all the rules. It shows things that you wouldn't normally see, or it shows depth where the depth you wouldn't normally see it. What does that matter? You've taken a nice picture and you've won the prize, you know. And you think, well, that's human nature. Sorry. That's the way it is.
I don't know whether John agrees with this, but I think what he's getting at is that can you get striking pictures that will win these competitions without having to go by actually producing a more naturalistic picture of what things actually look like, and that's more difficult than, in a sense, than doing all these pretty fancy synthetic pictures.
Yeah.
You're just taking the words out of my mouth, Andy. Yeah, you know, it's not a question of a 1.5 second exposure at f whatever it was. Yeah, it's all the other manipulations that come in, and a number of exposures and a number of hours of stacking and all the rest of it. To me that's artificial. I mean, yeah. I mean, the stuff that our lads are doing is bringing out information and is giving us a better picture, but it's a photography competition. It's not.
No, I agree.
It's not a photograph manipulation competition.
And if you look at Steve's Mars picture, I don't know how many frames he used or what percentage of them he used, but
I can show you actually.
I'm just wondering what a single picture like what Bill is describing actually looked like. But the thing that Bill can't get away from is the fact that your finished product has bits of markings which are real. Yeah. You can relate those to a map of Mars, and I'm sorry, but they really are there. Yeah. So I would argue that is not artificial. It's just a clever way of dealing with the optics.
Let me just share this with you.
Show us the original video, maybe.
Right, here we go. So this is the clip that I actually then processed to produce that image. It's a bit strange, actually. It looks, when I was actually looking at this at the time, it actually seemed to be better. I don't know whether it was just my memory kind of filtering, but I mean, you can see, obviously, you can see the markings. Sorry, that's
Very well.
wise. But basically, this is what I was starting with, and you know, then subsequently processed. And you can see that, you know, you can see the colour fringes. You can see the blue kind of to the bottom left, and the red to the top right. But then that's I'll just try find.
That is a great image.
I'll stop that. Just see if I can. Oops. If it's sat there waiting for me, which it might just be. 4100, is it this?
Sit down. Sit down.
Yeah, so sorry about this, just bear with me if I share. So this is the photos I processed it. Now, I mean, I ran that through Registax, and when I'd finished with it, there was a kind of bluish ring going round. There was a bit of a gap, and I just took that out with GIMP. In fact, I'll blow this up a bit just to give it a bit of a chance. So that's kind of what I got to after that. So bearing in mind there's a ring gone round it that Registax put there, which I think is an artifact of the processing. I then took that out, and then Rod subsequently processed this JPEG and kind of took some more of the fringing. You can see it's actually gone yellow around the top right, still blue at the bottom. But I mean, there's no two ways about it. That, you know, that has been processed. I was very, very, very pleased with the clip that I took, but the video clip that I took. But yeah, it's been processed. You know, to get to that stage.
Sorry, Steve. Is the reddish colour on the right-hand limb and the bluish colour on the western limb, is that real or is it aberration? What is it?
It's aberration. It's the atmosphere acting as a lens or a prism, because the, hang on, is it the blue light that bends more than the red?
I blame Isaac Newton for that.
Yeah. So the you know, the original image gets kind of slightly split. If Mars was dead overhead, obviously there'd be a few questions to be asked, but you know, if it's dead overhead, then that wouldn't happen.
I noticed that when you were playing the video that Mars was towards the bottom of the frame. Do you think if it had been central in the frame, there might have been a bit less colour aberration?
I don't know. I've actually got another one. Let me just.
I think the answer to that's no. It's the same.
It's. I mean, there were a few things working against me. It's actually going through two Barlows. I've got two times Barlows, and I put them both on, plugged one into the other, and then plugged my my webcam basically into those. So there's an awful lot of glass surfaces. You know, between the original light and what's being captured.
Was the image actually at the edge of the field of view of the telescope itself, or just at the edge of the field of your camera?
No, it was at the edge of the camera, really. I mean, I've got another one if I can just.
Your camera sensor is just 1/3 of an inch, like mine, isn't it?
Yeah, it's not kind of, I can't remember what they call it, but it's not a full.
No. So really, it's virtually in the center. Being on the edge of 1/3 of an inch is, you know, it's not the same as being on the edge of a APS-C sensor or 35mm sensor, full frame.
I still feel very surprised you're getting atmospheric chromatic aberration at 40 degrees.
I am.
Because if you'd see it in a star, if you had that degree of aberration when you look in a star, a double star, you see red on one side, blue on the other. You never do, not at that altitude.
Now, back in the summer, there was a BAA webinar where they were talking about these dispersion correctors, and somebody was saying they were using it on Venus and needed to when it was at 40 degrees. Now Venus is particularly bright, I suppose, but I'd say for Mars, I haven't been bothering once it's sort of up quite a bit, but I'm using the color filter, so that kind of suppresses things.
Well, I'm going to sit down and do some calculations afterwards.
I do have a table, and I'll find it, and I'll put it on the website of the angular dispersion as a function of the altitude.
Interesting.
And I agree with you. I did not think it was very much at that altitude. I think the trouble is the planet itself is so darn small that as a percentage, you know, it's quite measurable, it's quite visible. It's something you don't tend to notice as much when you're looking at Jupiter.
I think the other thing you need to remember as well is it wouldn't have been 40 degrees at that time. It was 8:45, not midnight. So, you know, it's been making its way up to 40 degrees. I'll check it out on Stellarium afterwards, but I'd guess it was probably more like 25 to 30. Yeah.
Venus certainly showed aberration in a telescope when it was down at about sort of 15 to 20 degrees.
Yeah,
that was very clear. But,
and as Rod says as well, it's a small image. It's why I had to kind of stick every barlow I could get my hands on.
Yeah.
To kind of boost it. So I mean, I don't know if they're making things worse just by having more glass surfaces in there. Certainly don't think they would have improved things.
No, it's just an atmosphere thing.
Yeah.
I actually have a corrector, but I never got really the chance to use it last night or any other night. I'm always so busy desperately trying to get everything set up and take any images at all. And I stopped about 1:45 in the morning, and loads of clouds were coming then and battling with the wind. It's very frustrating that I can't use the one thing that can stop it. But Registax does do a very good job of altering the blue and red channels to center them.
Okay, I'll have a bit more of a play around with that. I can do it in GIMP, but you kind of got to pull them all apart and then it's kind of line them up again by hand.
I think that's the other problem with doing any kind of imaging for data capture in this country is the bloody weather. The weather, you know, it's not like sort of southern Spain or northern Africa or whatever, where you get these sort of infinitely clearer. And somebody's mentioned Australia. It's just the weather here is just so poor for this kind of work, really.
But one thing in our favour is that the clocks have gone back, so now Mars is at its highest, more like 11:30 rather than 1 o'clock. So that's in our favour. At any rate, it's a little bit more of a respectable hour. John Arnold, do you think we ought to leave the Moon book until next time?
Sneak preview. Yeah, this is the 3 volumes. Allegedly, it's a handbook. It's a lot more.
Quite a bargain. That price, isn't it, for 3 huge volumes?
Yes, yes.
What was the price?
50 quid off Amazon.
Fantastic.
But I'll say more about it some other time. It would be a shame to squeeze it in now, I think.
In November, yeah, that'd be great.
Mm.
Well, I'm aware that it's 5 to 10 nearly, so unless Karen's cat's got anything to say. One point I thought, oh, was that Karen's trouser leg? But it was a tail.
Well, I was going to be asked to be excused because I'm making tea and I haven't had my tea yet. So
You always say that.
I know. Well,
You're supposed to
no,
look after your eating, you are.
yeah, but diabetics these days, it's not like in 50 years ago where you had to eat at set times. It don't work like that anymore.
Just before you go, I've been secretly in contact with Robert. He